Okay, I think that we can get started now. So again, good morning, everybody. It's a pleasure to be here this morning. Let me start by reviewing why we are here today. So the purpose of this conference is to provide you with some insight over how SHEALTHY project is going to impact on food sector. This conference has been organized in the framework of the European Union Green Week, and when we are done, we will have three main things with us. So first of all, consumer insight, thanks to the presentation by Professor Davide Giacalone from University of Southern Denmark. Secondly, technologies overview that we are going to implement in SHEALTHY, thanks to the presentation by Oscar Rodriguez from Iris Technology. And business modeling outline thanks to the presentation by Assistant Professor Geoffrey Halagar from the Wageningen University. So what is exciting about this? Today you may learn more about how we are dealing with the zero polluting food processing. So let's jump in SHEALTHY core. I will be introducing you with what is the SHEALTHY project, basically presenting your consortium, the key objectives that we are going to achieve, what is the market demand, so the problem we are going to solve, and the business case we are implementing for gaining our key impact. But first of all, who am I? I'm Simona Miccione and work for ENCO, which is the coordinator of the SHEALTHY project. And within SHEALTHY, I play the role of the intellectual property rights and exploitation manager. What does it mean? That I have to ensure that all the results from the project are going to be used by other audience and that all the intellectual property rights are properly secured. Here you have my email address. And in case you want to reach me out, do not hesitate to contact me. So let's go on with what is SHEALTHY project. SHEALTHY project is our research and innovation action funded by the European Commission and specifically by the Horizon 2020 Research and Innovation Program within the Sustainable Food Security Work Program, which is oriented to sustainable and competitive agri-food industry and addressed to healthy and safe food diets for all. It is about a project of 4-year project. We are quite in the middle of the project, as you can see. We are benefiting from quite €7 million of EU contribution. Here you can see the SHEALTHY consortium, which mobilized a multi-actor interdisciplinary partnership composed by research institute, industry, micro, small, medium enterprise, universities, and association. And we try to reach a good balance in terms of geographical coverage. So you can see the 8 countries involved in SHEALTHY consortium and extraordinary mix of pocket of knowledge ranging processing, the food science, the food engineering, management, socioeconomic, and consumer science. Here you can see the SHEALTHY objectives. So basically we are aiming at combine non-thermal preservation methods, so mild technology, first at lab scale, and achieve a sustainable extraction of bioactive compounds from fruit and vegetable byproducts and co-products. This from the technological point of view. Then in terms of management, we are going to define business models and novel sustainable logistics system tailored to the needs of micro, small, and medium enterprise in the food sector. Then what we are going to do is to upscale and demonstrating technologies and business model at pilot plant. In fact, we are going to run 11 pilot trials with food companies all around Europe. And then when upscaling, demonstrating such technologies and business model, We are going to assess the environmental, economic, and social sustainability of the processes, but also the food properties of the prototype that we are going to produce through the novel technologies. But SHEALTHY, why is so innovative? Because we want to respond to two basically consumer needs and micro and small medium enterprise needs. In fact, consumers are demanding food that is healthy, fresh, sustainable, locally produced, convenient, but also nutritious. And what are going to respond to micro and small and medium enterprise needs is they want to have food processing technique and logistic system that are, first of all, flexible, that could be seasonal based, so because fruit and vegetable respect seasonality aspects, and could be effective and sustainable. So in SHEALTHY, we are going to implement two different business cases. One, the minimally processed fruit and vegetables, so basically fresh cut and salads, while juices and smoothies, so the blend between not only fruits, but also fruit and vegetables. So we are going to implement combination of non-thermal salinization, stabilization, and preservation method with the general objective to optimize the preservation of nutritional and organoleptic properties. So we want to preserve the natural occurring properties of fruit and vegetables. Here you have the SHEALTHY concept. So basically solutions that are going to be implemented in pilot trial SMEs, resulting in new regional food system. So you can see here how complex is our ecosystem. And we want to bring together primary producers, so basically farmers and consumers in a farm to fork process with food companies. And here you can see on top the business case one, so minimally processed fruit and vegetable. So we are going to implement salinization, preservation technologies like ultrasounds, electrolyzed water, or bioactive coating, active packaging, intelligent packaging. While in business case two, so fruit and vegetable based juices and smoothies, we are going not only to optimize salinization technology, but also stabilization like ultrasound, high pressure processing. And this overall ecosystem, you can see how collaborative business models are the key element for bringing together all the food actors along the value chain together with logistics system to ensure not only freshness, the authenticity, but also the traceability of food products. So here you can see the key impacts that we want to achieve through our SHEALTHY project, basically to prolong the shelf life of fruit and vegetable products, to reduce the food loss, especially during the post-harvest phase of fruit and vegetables, but importantly, to increase the natural value of minimally processed fruit and vegetables and juices and smoothies. And from the market and business perspective, we want to support micro and small and medium enterprise to increase their market orientation in terms of fruit and vegetable, responding to consumers' expectation. So here you have the agenda that you already know. So we go through consumer expectation, presentation from Professor Davide Giacalone from the University of Southern Denmark. Then we jump to technology aspect with Oscar Rodriguez from Iris Technology, and then business model with Geoffrey Halagar from the Wageningen University. Then we have a question and answer session. So I would like to ask you to type your question in the chat, so we are able to see your question. We are happy to respond to your curiosity, to your doubts, and to your question. But before leaving the floor to the next presentation, I would warmly recommend you to visit our website to follow us on our social media and to subscribe to our newsletter. So let me thank you all for the kind attention. And now I leave the floor to Professor Davide Giacalone. So thank you so much.
Thank you, Simona. I'm going to share my screen. Can you hear me?
Yes.
Very good.
We can also see you.
Great. And I hope you can also see my screen now.
Yes, properly. Yes, thanks.
Very good. So good morning, everybody. My name is Davide Giacalone. I'm a consumer scientist working at the University of Southern Denmark. And in the SHEALTHY project, we work primarily with consumer involvement, and I'm happy to present some of the work we have done together with the SHEALTHY partners today in this presentation. I'm going to try to keep it short and to the point, which is not usually my strong suit, but there will be time for questions afterwards, and of course those questions are very welcome. So I am not going to repeat some of the things Simona said about the project, but just to emphasize the main ideas for the background for working with consumers in the SHEALTHY project is that we see that there is an increasing demand of products that have healthy and natural attributes, and that consumers increasingly respond to things such as freshness and naturalness. And of course, fruit and vegetables are already seen as healthy products, generally speaking, because they are, of course, we know that they are key elements of a healthy diet. And we try to respond to this demand with the non-thermal processing technologies, which I think the next presentation is going to go quite in depth with, but generally speaking, refers to processing that uses mild temperatures and a limited amount of physical and chemical processing aids for the processing of fruit and vegetables. And of course, there are already a lot of studies or ongoing studies as well that suggest that these methods are quite promising to better preserve the quality of fruit and vegetables, as well as derived products such as juices and smoothies. And these benefits relate to extending the shelf life and having a better nutritional better retaining of nutrients, and also having a sensory quality, so a taste and flavor profile that is closer to the fresh products. So there are all these potential benefits, and of course, as food scientists, people normally, we try to focus on specific aspects, and we can get we can appreciate the physical and chemical advantages of treating with non-thermal processing technologies, but we need to take into account the fact that consumers are typically not necessarily seeing things in the same way. They're known to take a conservative approach, and also they are known to have mistrust sometimes for specific processing methods. For instance, there is a lot of evidence that irradiation is one food processing method that consumers do not respond well as well as others, but generally they do not necessarily see the benefits in the same way as we do, and they also tend to think of the product as a whole. So we need to understand how consumers perceive products that are treated with these novel technologies, and that is of course both important from a commercial exploitation point of view, so in terms of building business models around these technologies, but also from a consumer advocacy standpoint, so that consumers can be correctly informed about the benefits of these technologies. So with this background, we set out within SHEALTHY project to understand a little bit better how consumers perceive fruit and vegetables treated with non-thermal processing technologies. And this was a very collaborative work, so it was together with the other EU partners. So you will see that the activities span across several countries as well. So the first thing we did, I'm going to try to really keep it short and to the point. The first activities we did in SHEALTHY was qualitative research. So we did focus groups in 6 countries where we had little short of 100 consumers, and they were balanced by age and gender. We discussed several things with them. I'm going to focus on, for the most part, on their perception of non-thermal processing technologies. And the bottom line, or the first thing that we discover, is that consumers do not necessarily have a lot of knowledge, or really do not have almost any knowledge at all of non-thermal processing. In fact, when we asked them, when we discussed processing with them in the context of fruit and vegetables specifically, most of the discussion, or most of their ideas were related to what happens during farming. So particularly, organic farming and use of pesticides was frequently mentioned as related to processing. But basically, everything that happens in the post-harvest phase, you can say, so the washing, processing, the cutting, the peeling, coating, and so on, putting in a modified atmosphere, packaging, all these steps consumers have no or very vague idea of, and they're not necessarily seen as processing in their mind. So that was one, a very clear finding from this focus group's results. However, when we introduced them to the context of non-thermal processing and gave a few examples of this, then they could relate to it to a certain degree. They also demonstrated some knowledge. For example, waxing of apples was something that many consumers were aware of. So we could have a discussion around that when we provided a few examples. Now, generally, when we talk about, I'm just trying to summarize what were the main concerns that consumers had towards these technologies, and what were the main benefits that they saw in it. With respect to what they were concerned about, so one of the major themes was about the sensory quality. Will this affect how the food is going to taste? And we know that sensory properties, taste is a huge driver in what people choose to eat. I mean, people will eat what they like to a certain degree. And this was also confirmed in our research. So affecting the sensory quality was something that consumers were potentially very paying attention to. Another thing is, of course, whether this would have any harmful effect on health. And of course, they would expect that the certification bodies are vetting these novel technologies. Generally, there was mistrust due to lack of knowledge. So a lot of consumers do not feel that they know enough to actually evaluate the possible risks and benefits of this technology. So they would expect to be adequately informed about it. And also, a lot of consumers, or some consumers at least, they mentioned that they are concerned about the possible price increase due to this additional processing. And a few people were actually worried that this could be just a marketing trick to increase the price of fruit and vegetables without necessarily having a substantial effect. So this was some of the themes that consumers came up with during the focus groups. And with respect to benefits, they thought that well, extending the shelf life, if that is possible, that would be a nice idea. A lot of consumers, especially in the younger consumers, they were very aware of sustainability. So they thought that it's nice if this could help in reducing food waste, having less food wasted. Some people thought that if it can improve the safety and make the fruit and vegetables safer, that would be a nice benefit associated with this additional novel processing. And some people also thought that if it can improve somehow the taste or the sensory quality of the products, that would be a nice idea as well. When we are trying to quantify the responses a little bit, this is what came up. Most of the benefits related around shelf life extension, so wasting less food, having a healthier and more nutritious foods, and better hygiene and safety, essentially. Whereas from the concerns point of view, most quotes from the consumers related to potential changes and loss of sensory quality, so affecting the taste in a negative way, safety risk for health, and potentially resulting in a higher price. Now, of course, qualitative work isn't necessarily very well suited to making quantitative conclusions on what consumers perceive. So the next step that we did in the project was actually to move on to do some quantitative studies instead. And the other major activities that I'm going to talk to you about is an online survey that we did to confirm the results. In this case, we had around 1,000 consumers, and this was done online. Also because in the meanwhile, the coronavirus pandemic started, but it was going to be online anyway, and it was a choice-based conjoint. I'm going to show you what this means in a second. And we also asked them some information about their storage and their food waste habits, and also some personal background questions. So the first part of the main part of the survey was a choice task where we presented them with different case studies related to some of the products that we work with in the SHEALTHY project. So one was about juice, and one was about iceberg salad and cherry tomatoes, and this represented three different processing methods: high pressure processing versus pasteurization in the juice case study, novel versus conventional washing in the iceberg salad, and active versus conventional packaging in the cherry tomatoes. And then what we varied in the product, we gave them different descriptions, and then they varied in terms of benefits. So we had one related to the product being healthier and more nutritious, one related to the product being flavorful and natural and having a more natural taste, and one about having a longer shelf life. And finally, we varied this product in terms of price. So we had a reference price that was difference between different countries that was based on actual market prices. And then we added a 30% to have a low and high price range. And this is how it looked like, how the task looked like for a consumer. So you had the three products. You did this several times so that all combinations could be evaluated. And then, so there would be a price, a benefit, and a type of processing, and consumers had to choose which one they would purchase. And they also had the option to say that I wouldn't choose any of this. Now, just to summarize, also in the interest of time, basically this is a plot that shows what was most important to their choices after we cleaned out the consumers that didn't make any choice. And we did this both as an overall level and also on an individual country level. I'm just going to focus on the overall level also because we didn't necessarily see major differences between countries. But at an overall level, we can see that actually the type of benefit claimed in the product was the most important driver of their choices. Processing and price, they had a similar influence or similar effect on consumers' choices, at least when it comes to iceberg and tomato, whereas only for the juice, processing information was actually more important than price. And this could mean, I mean, in theory, it could make sense because juice, it is a more processed product than whole produce. So it could mean that consumers think more about processing in the context of a product like juice than a product like cherry tomatoes. So what does this mean? What is the direction of the effect? So let's have a look at that in the next slide. And I'm going to start from the central column, the benefit that we claim that the product has. And basically, we can see that benefit related to having a more healthy and nutritious profile was the most effective one. So most people chose the products when this claim was present. And the close second was having a better taste profile, taste and flavor profile. And this was also quite positively received, and extended shelf life wasn't necessarily a strong driver of consumer choice. So generally speaking, the health and taste benefits were much more strongly impacting consumer choices. With respect to processing, this was really interesting because We didn't see a major difference in the two levels that we presented, so the conventional and the non-thermal processing, but in fact, there was a preference for the novel processing, and this is of course a promising results with respect to using these technologies, and that of course has to do as well with the fact that we possibly used a consumer-friendly language to present them. And with respect to price, as you would expect, people chose the products more often when they had the reference price. So the reference price was the lower price. So price, as I mentioned before, was the least important of the three aspects. So that's nice, but basically, people, some people at least, would not choose it if there is a price increase, and that's what our results show. I'm not going to go, in the interest of time, in the differences between countries, but like I said, we did not see major differences between the countries, so it was more a matter of degree rather than actual differences. Very quickly, I'm not going to talk too much about food waste, but we asked them a series of questions about what they typically discard in their home. We know the fruit and vegetables collectively are a big part of household food waste. And our results show that it is particularly leafy green vegetables that get discarded more often, and tomatoes and bananas were the most often, the second and third most often discarded fruit and vegetables product among EU consumers, with a few differences between countries. And then we also asked, just very quickly, what were the reasons for discarding fruit and vegetables for the most part. And basically, they gave a lot of reasons, but the majority of it has to do with sensory quality decay. So people inspect food either by looking at it or by smelling it. And so the presence of visible molds or the presence of bad smells and bad taste were, for the most part, indicate as reason for discarding fruit and vegetables. So of course, to the degree that non-thermal processing can increase the shelf life, so can maintain the sensory quality, including appearance of food, of fruit and vegetables longer, this should contribute to of course, reducing as well household food waste. So just very quickly, some bottom line conclusions. Novel technologies, food processing technologies in general, are not top of mind of EU consumers. Lack of knowledge about this technology might be a potential reason for concern, a potential impediment to consumer acceptance of fruit and vegetables products treated with non-thermal processing. But we found in our research that specific benefits associated with these products are so personal benefits are much more relevant to consumers than processing information. And therefore, communicating about specific benefits coming from this technology should in fact increase acceptance. And also related to this, we did not really find any evidence that when communicated in a consumer-friendly language, that consumers have a problem with non-thermal processing technologies. We found that consumers paid more attention to processing when it was in the context of fruit and vegetable derived products. So this might be more relevant for smoothies and juices than for whole fruit and vegetables. And as I mentioned before, consumers aren't necessarily aware of what happens to the fruit and vegetable during the post-harvest phase. So that might be the reason for this particular result. Health and nutritional benefits, most effective type of claim. And so the possibility of delivering on these benefits through non-thermal processing should be emphasized in consumer communication. However, taste was also a very strong driver of consumer choice. Also in the focus groups, people mentioned that they generally buy the fruit and vegetable because they like, or that their family likes. So it's very important that the flavor, the sensory quality of the fruit and vegetables treated with non-thermal processing methods is at least on par with their conventionally processed counterparts. And this is, of course, a very big, important part of the continuing work that we do in SHEALTHY. So sensory studies are needed to to make sure that that is the case. With respect to food waste, consumers in EU mostly discard fruit and vegetable after visual inspection, and this is mostly due to sensory quality decay. So there is a potential of non-thermal processing to help with reducing food waste. So we, as I mentioned, leafy greens and tomatoes were most often mentioned as discarded fruit and vegetables. Besides sensory quality, there were a series of factors that were not really product related, but for instance, one that was interesting perhaps to emphasize was that a lot of consumers, especially young ones, complained about suboptimal package sizes. For instance, for people that live alone. And also we observed during the quality work that there is definitely a lack of knowledge of correct storage practices. So these are also non-product related factors that might explain why we see so much fruit and vegetable being wasted in households. And that was it from me. I thank you for listening, and there will be time for questions afterwards. Like Simona mentioned, I would really encourage to look at the SHEALTHY profile, especially if you would like to read more details about all this work. So we have a public report on that. We have some publications on that, so please go check that out. And yeah, any questions are welcome, and you're also welcome to follow up with me afterwards.
So thank you so much, Davide, for your presentation. And again, I would like to encourage you to type any question that you may have in the chat, so we will be happy to answer you. So again, Davide, thank you a lot. And now the floor is for our senior scientist from Iris Technology Solution, Oscar Rodriguez. So the floor is yours. Thank you.
So thank you. I will share my screen. So please confirm that is good.
Yes, thank you.
Okay, so thank you and good morning, everybody, and welcome to this presentation entitled Combine and Optimize Mild Technologies Towards Less Polluting Technology. So traditional food processing relies on heat to kill foodborne pathogens like bacteria, viruses, and parasites. I have to say that even if we are going to talk about mild technologies, thermal technologies are the most used right now in the food industry. For many foods, heat works well, but for others, it doesn't work well. Then there is this consumer demand for minimally processed food, such as salads, fruits and vegetables, juices, smoothies, and they also require that those products have extended shelf life and they are safe to eat. So when we are talking about mild technologies, we are talking about technologies or methods that do not use heat, but neither freezing. We are talking in the middle of those opposite extremes. And we are looking for methodologies that destroy the pathogens while retaining the sensory attributes and the nutritional content similar to the raw or the fresh product. This is what we are looking for. And according to David, he mentioned this is what the consumers want now. So the mild technologies are at different stages of development, but they have this potential to destroy the pathogens and offer a product with similar characteristics to raw or fresh. In the SHEALTHY project, for example, well, we are looking for develop, optimize, and find a combination of non-thermal technologies, and we are working to sanitize, preserve, and stabilize methods to improve the safety while preserving the nutritional quality of and prolonging the shelf life of minimally food and vegetable products. The idea of the project is to validate these technologies into two business cases, as Simona mentioned before. So we have in a first business case, the sanitization of fruits and vegetables. And for this, we are studying technologies like the powered ultrasound, the blue light, the high intensity pulse light, the electrolyzed water, the plasma activate water, and also for extending the shelf life, we are working with packaging, in more exactly active packaging. But we also have a second business case, and we are looking for the stabilization of fruits and vegetables, juices, and smoothies. And for this, we are working with powered ultrasound as well, and also high pressure processing. So we are going to talk about all these technologies one by one during this presentation. So let's first start with light technologies. The use of light in the sanitization of fruits and vegetables has emerged as a non-ionizing technology. It means that it does not produce any ionized compounds that could affect or could be harmful for the consumer. The photodynamic inactivation, what we see in this slide, occurs when the light at a specific wavelength triggers some reaction, oxidative ones, inside the microbial cell. So those reactive species have a cytotoxic effect, and they produce the bacterial death. In the SHEALTHY project, we were working with two different kinds of light technologies. The first one is the high intense pulse light, which could be delivered continuously or in pulses. So when it's delivered in pulses, it has more power. So it's able to penetrate the product a little bit further, but as this is really short in time, the heating produced is on the surface of the product, not in the bulk of the product. So we don't have extra heating of the product. The high intense pulse technology comprises the ultraviolet, the infrared, the visible spectra to produce lethal dosage for bacteria, fungi, and virus. In the other side, we have the blue light. The blue light is obtained by the use of light-emitting diodes called LEDs, and the light ranges between 400 and 420 nanometers, and to induce the phototoxic effect we commented before. This light is less powerful, has less power, so the exposition is recommended to be longer. So we can think about the application of blue light during, for example, a storage process or a refrigeration process, where the product is going to be exposed to the blue light during longer times. At IRIS, we are working with the blue light, and what you see on the right of your screen is a prototype, a lab prototype of a blue light chamber for application of blue light, of course. And as you can see, we have made tests with a small product like cherry tomato, I'm sorry, or pears. But also we have been able to test the effects of the blue light technology on salads and leaves like spinach, lettuce, also pears, apples. And this technology is giving us more and more results, but we still are in a testing part. So we are looking for find an optimal combination of parameters that give us a good product at the end. Then we have another technology which is called the plasma activated water. So the cold plasma, which is an ionized gas that is produced by applying energy to a gas or a gas mixture consists of active particles such as electrons, ions, free radicals, or atoms. Those reactive oxygen species serve as a germicidal components with the capacity to damage proteins or the DNA of microbial cells. But take into account that the produce, I mean the fruits and vegetables or the leaves, has a irregular surface, the use of plasma has not reached an ideal level. So it has been demonstrated that the plasma activated water could have this extra benefit. This could outcome this obstacle. So it could arrive to all the parts of the product when use it for sanitization. The active species are safe or stored in the pools and the plasma activated water, and they are stable over a longer period of time. And compared to the plasma, it gives us a better outcome in terms of antimicrobial efficiency. So the effect of the plasma activated water relies on if the combination of those reactive species, but also the low pH of this water. This low pH is the result of the formation of acidic compounds like nitrose and nitric acid. This plasma activated water is considered to be stable up to 48 hours when it's frozen, and once it's melted, it can last a couple of hours to its use in the washing process. In some studies, the application of plasma activated water could induce a reduction of the antioxidant capacity or the antioxidant properties of the products compared with the non-treated sample. But during the storage or in the long term or during the shelf life studies, it was observed that those products treated with plasma activated water keep the or conserve the antioxidant activity longer or better than the control untreated product. Some little effects on the color and the texture and the food ingredients are observed, but they are not so significant. And antimicrobial effects are observed after 2 minutes of contact time. So this is a good technology to be taken into account. Then, and talking about water, we have the electrolyzed water. Electrolyzed water is produced by passing a diluted salt solution through an electrolytic cell, within which the anode and cathode are separated by a membrane. So by subjecting both electrodes to direct current, we produce negatively and positively charged ions. This process rises up 3 kinds of electrolyzed water: acidic one, basic, and neutral one. In the frame of the SHEALTHY project, the neutral one is the electrolyzed water that we are using. Why? Because it's less oxidative and it's less corrosive. But at the same time, it conserves all the antimicrobial capacity. I'm sorry. The main reason for this popularity of the main reason for the use of the electrolyzed water is the simplicity of the production and the application, and is effective against a long variety of microorganisms. The application in washing processes is very fast and it takes less than 1 minute. So once we were talking about technologies for washing, but now we also want to talk about technologies for the packaging or for conserving the products during the shelf during the storage. So we are thinking about the packaging that is necessary to protect the product against many factors like the light, which can catalyze reactions that we don't desire, or they could promote oxidation or degradation of vitamins. Also, we think about a package that is able to protect our product from impacts and also from the surrounding contamination. But also we need a package to prevent the transfer between the surrounding and the food product. We always thought about a package to be inert and that it does not interact with the food product. But when we are talking about active packaging, we are talking about something different. We need that the package interacts with the product. And this interaction could be done by including components into the package. And those components are able to release to the product or even absorb from the product certain substances. For example, if we are looking to release, we might be looking to release products like with antimicrobial or antioxidant properties. But when we are talking about, for example, capture or absorb, we are interested that these compounds absorb, for example, the dissolved oxygen or the excess of moisture. So the active packaging is a solution that should be tailored to the needs of each product. This package is a function of the type of product you want to treat, to have, the function of the package, and the packaging system. So this is a really interesting technology, and it can fit to many products, and it can give us or remove some problems we have during the storage. Now we are talking about another technology, which is the ultrasound. So sound is a variation in pressure or a vibration that moves through the environment. Could be the atmosphere, could be a gas, could be a food item, could be water, could be a juice, a smoothie. This technology is considered as non-invasive, is used to promote physical and chemical effects on the product, does not produce any dangerous radiation, and it operates at room temperature. And how it works. So go here, click. When the ultrasound is applied, it propagates through any biological structure. Let's think about the juice. So when it propagates, it promotes the compression and the compression or expansion of the medium particles, resulting in the production of a high amount of energy. In a liquid media such as water, which can contain dissolved gas, they can expand, promoting a bubble, and compress, but then collapse. This collapse is violent and can generate localized temperature and localized high pressure, what we call hot spots. They are really limited in time, and they can reach temperature theoretically as 5,000 kelvins. But as they are really short in time, we don't appreciate this increase of temperature in the product. So this bubble collapse is the main cause of the microbicidal effects of the ultrasound application. But first, let's talk about how the ultrasound can be given to the product. We have the ultrasonic bath with many of our, we have the ultrasonic bath in the first case, And in this case, we transform the low frequency alternating current into high frequency sound waves using ultrasound transducers. These transducers could be attached either to the bottom or to the walls of the vessels where we put our product or we submerge our product. But also, if we want a direct application of the powered ultrasounds, we can talk about ultrasound proofs. And this is a really more direct application of the ultrasound through a small proof. The selection of one or the other way to give the ultrasounds depends on the product you want to treat, depends of the regime, if you want to work in batch or a continuous mode. It depends on the intensity that you want to give to the product. It depends on many factors and should be chosen really carefully to not get an unpleasant effects of the power ultrasound application. So the inactivation of the microbes is a result of the cavitation process, and mainly is focused on the breakdown of the cell walls and the cell membranes, the breakdown of the DNA structure, or the hydroxy peroxide formation during the cavitation process. But also the ultrasound can be used in many other applications. And now we are going to jump to the second business case related to the stabilization of juices and vegetables. So the ultrasounds can be used for preservation, but also for extraction. When we talk about extraction, which is also one of the activities in SHEALTHY project, we are talking about the reduction of the extraction time, the reduction of solvent use, and the reduction in the environmental impact when using ultrasounds. The way to use, or let's say, how to choose the best way to apply the ultrasound, it depends to find a right balance between safety and the quality. And this balance or the effect that we achieve depends in many cases of intrinsic factors, which are the juice matrix and the structure and the composition of the juice, and also the external factor, as I mentioned before, the amplitude of the ultrasound, the acoustic power we are giving, the processing time, and also the temperature. And here is the combination with other technologies that allow us to obtain different results. So in the juice industry, the process for obtaining the juice is simple. We take the fruits, we prepare the juice, and then we apply the ultrasound for the stabilization. This technology has many benefits for the industry. For example, the reduction of the processing time, the reduction of the temperature of the processing, and the reduction of the energy consumption. Also for the consumers, it has health benefits because it improves and sometimes it increases the antioxidant activity of the juices. The sensual acceptability is good and the nutritional value is conserved. We are able to keep it as fresh. However, this technology as all has limitations, but this limitation could be overcome with the new developments on the industry of the ultrasound manufacturers, but also the combination of the technology with other techniques. And the idea of the SHEALTHY project, or what we are working for, is to take our ultrasound processes from the lab, taken to a pilot, and being able to replicate those results, the good ones, into the industrial sector. And last but not least, we have the high pressure processing. This technique is very well known and is very well applied around the world. because it's fast, it's uniform, it doesn't use chemicals, and it doesn't need or deliver extra heat to the product. Basically, you take your product, you package, then you move it into a vessel, then you, let's say you put water into the vessel and open the bubbles up to a desired pressure. Let's talk about 6,000 bars. And in a short time, you are able, when you reach this pressure, you leave it a short time, and then you release the bulbs, remove the product, and it's ready to be used. This technique is better than those thermal ones because we are sure that it's isostatic, I guess. I forgot the word, I'm sorry. And you get the same value of pressure all around the product. In every single point of the product and every single point inside the vessel, you have the same pressure. It's different to the thermal technologies where you have to wait until the center of the product heats up and reaches the desired temperature. This technology has been proved to be effective against mold, yeast, parasites, bacteria, and spores. And this effectiveness is thanks to the change in the cell morphology, then the naturation of proteins due to the break of the peptide change, and also the modification in the cell structure that affect the permeability of the cell membrane. Yes, as we mentioned at the beginning, we are not looking only to study these technologies alone. We are also looking for studying their combination. That's why in this stage of the project right now, we are testing the combination, for example, of the power ultrasound and the electrolyzed water for sanitization. Also, the power ultrasound with the plasma activated water. The plasma activated water as a washing method, then the active packaging. And we are now thinking about washing with electrolyzed water or plasma activated water, any of those, not both, and then applying blue light during the storage. In the business case number 2, I'm sorry, oh, it was here. Yes, we are talking about using the power ultrasound as a pre-treatment before the application of high pressure processing. So we are working on that, and we hope to have good results that give us that the sum up of those technology can be complemented. So that's all. And I hope we can have good results and we are able to take it to the industrial scenario. Thank you for your attention. Sorry for taking too long. And it was Oscar Rodriguez. So for any question, please type it in the chat, or here is my email if you want to write something. Thank you very much. Bye.
Thank you so much, Oscar, for your presentation. And now I'll leave the floor to Geoffrey Hagler from the Wageningen University. So thanks again, Oscar.
Thank you, Simona. I'm now sharing my screen. And do you see my screen?
Yes, if you go into presentation mode, please.
Yeah. Okay, I assume you all see my presentation mode screen now. Well, thank you, Simona, for giving the overview of the SHEALTHY program. And to thank you to David for presenting us the consumer preferences, the insights on consumer preferences, their comments and remarks, not only on the product quality attributes, but also on the remarks, comments on new technology and how to deal with that in their view of consumers. And thank you, Oscar, for your insights on the functioning and the benefits of the new mild processing techniques. And ultimately, the companies are in charge of implementing these new technologies, implementing in such a manner that they can reap the benefits of those technologies and that they can deal with the functioning of those technologies, new technologies, within their overall operations. And indeed, companies have to connect to the consumers and have to deal with also their doubts and have to achieve ultimately and serve their the customer preferences, the consumer preferences. So ultimately, you could say that is a challenge and for companies. And business models will support in dealing with those challenges because they are the logic structure in which technologies fit in the operations and fit in with the trying to reach the consumer preferences. This presentation on business models is a joint effort by Camilla Silva de Matos and Justina Pellegrina and myself working at Wageningen University at the Business Management and Organization group. So talking about business models, let's first set the scene for those business models. And again, connecting to what Simona already said, she said something about the agro-food ecosystem. Well, let's now have a look at that agro-food ecosystem, which is basically a supply chain within the middle, let's say, the company with the new technology to be implemented to reach out to the customer, the supermarket where or a shop where the consumer can buy its products, and on the other side, the primary production, the farmers. So this is the basic supply value chain, and the majority of companies are SMEs, small, medium-sized companies. And indeed, talking about challenges of implementing a business model induced by introducing the new technology, that is a challenge for certainly for small and medium-sized enterprises. Why is that? Well, they are small companies. Their resources are limited in the sense of capital, in the sense of knowledge and knowledge of the processes, knowledge of the market, and so on. So indeed, when talking about the SHEALTHY program and the tailor-made issues tailor-made to SMEs, that's certainly in need to make the business models also tailor-made to SMEs, how they can cope with ultimately with the new technology. But as we know, the basic supply chain value chain gives a nice overview, but actually a lot of chains are also are longer and, let's say, more complex. In the sense of complexity, then we talk about partners on both the downstream and the upstream. So talking about suppliers, talking about distributors, talking about customers being shops, markets, talking about consumers. And ultimately, you could say that the consumer is and her demands are in the lead to drive the value chain and the value chain to achieve the preferences and reach out to the preferences of the consumer. So that's the alignment on the level of the value chain. And when demarcating to the company. And when looking specifically at a company, we see different elements within a company. And when a new technology is introduced within a company, then the different elements like the information technology, the supply management, the finance, the human resource, so the knowledge, the operations, the logistics, they all should adapt in a certain manner to that new technology to make that technology effective within the context of that and within the environment of that company, and to be able to reach out to the consumers, to the market. So reaching out, meaning, and dealing with the different elements means that those elements should be aligned to be able to get the correct manner to reach out to the customers, the suitable manner to reach out, to convince the consumers that the mild processing technology has a beneficial effect on the fruit and the vegetables. It could lead up to an alignment with the suppliers upstream, in the sense that possibly they adapt something on the raw material, which is the products which they produce, bringing it to the processing company. And indeed, within the company itself, the relations between the different elements should be aligned as well. So there's an alignment on the level of partners within the supply chain, and an alignment between the different elements in the companies themselves. So it's not only within the company, the processing company, but also looking at suppliers or looking at distributors. The different elements should be aligned, and internally and externally to their partners. So when introducing the new technology, it can trigger indeed the benefits and new values, like the nutritional value, the longer shelf life, the healthier, and with that achieving and the customer preferences, and also taking away their doubts on possibly on certain technologies. But introducing those technologies can also imply changes in their operations, in their human resources, in suppliers, how they supply, or possibly other different products that will be supplied, and can cause changes to customer and consumer preferences. Reach out to new markets, to new consumers, for instance. And all that is linked up together. There is the interdependency. They all need to cooperate. The elements need to be aligned, and the partners need to be aligned to be able to reach out to get the technology working efficiently and effectively within the company, within the value chain, and with that achieving the consumer preferences. So changes are triggered in processes, in relations between partners, in distribution processes, possibly other customers, consumers. And then two management processes need to be dealt with in parallel to be able to create those new values and to capture them. Creating the new values by introducing the technology within the operations in such a manner that it works efficiently and effective, and to capture the value in the sense of, well, reaping the benefits of that technology, looking at the consumer and convincing the consumer to buy, and for the company to be able to sell the new product or the product improvement realized by the new technology to be implemented. And then we're talking about technology assimilation and business model innovation. So technology assimilation can be defined as a process within organizations that includes the initial evaluation of the technology, its adoption, and the full-scale deployment. Ultimately, a company needs to benefit, so it needs to embed that new technology within its organization. And the business model represents the business logic of a company, describing how it creates, delivers, and captures the value. So knowing which kind of value you want to create, how you can do that, also in reaching out to customers that they ultimately are going to pay for the products in line with the more beneficial quality attributes that the product has due to that new technology. And when dealing with those changes, then the third concept comes up, the business model innovation, BMI. And that compromises changes in modes of value creation, value delivery, and value capture in the existing business. So I hope you understand that indeed, when dealing with new technology, it's not a matter of pushing the button and it works. No, it's looking at the company, understanding how it functions, looking at your suppliers, looking at your customers, consumers, and then trying to embed that technology in such a manner that you can really reap the benefits from that new technology. And then you have to deal with factors that influence, as a company, you have to deal with factors that influence the assimilation of new technology. Based on literature research, we got a number of factors that influence the technology assimilation. We can go into that, but also looking at the time, I will leave it up to this listing, also to give an idea about, let's say, the complexity of embedding the new technology within its organization. And then the business model innovation, also factors influencing that business model innovation. Factors really that influence and make changes happen within, and factors that influence those changes, like the collaboration with business partners, indeed the alignment between the different parties involved, and that's just one of them. Also here, looking at time, giving the overview and trying to convey, let's say, the complexity and let's say the multidimensional idea about, okay, when changing my company, what do I have to deal with? Based on research done already in previous period, we came up with some first ideas about approaching business modeling. And I want to introduce three ideas of how to approach business models. And indeed, I will be a bit brief on that. The first business model idea is the technology-induced incremental quality improvement. So that is, in short, the way of a product improvement, an existing product improvement. What's necessary over there? It's an existing product improvement. So the company aims at an existing market, but still there is the uncertainty whether or not that consumer will buy the improved quality. Of course, there is a kind of a barrier in the costs and apparently the lack of financial resources within that company. And of course, a kind of a barrier is as well, let's say, the technological embeddedness, embedding of that new technology within its operations. And then we're talking about, let's say, the business model based on the idea of existing product improvement. The second idea is extends that first idea more in a radical manner, because it's not on the existing market, but it's going to a new market. So in that sense, the knowledge of a new market becomes very important, and the resources also, not only for on the technology side to deal with that new technology, but also to be able to reach out to new customers. That is also a very knowledge-intensive approach then. So communication and promotion can be barriers, and we heard David talking about those issues as well. The third business model idea that came up, the pattern that we saw in our research, is the efficiency improvement. So that's implementing new technology with the aim of improving the efficiency of its organization. And there, the main barriers are not, let's say, on the side of consumer customers, but the main barrier are much more internal on the organizational and operational operations, the logistic operations, and the possibly the competencies that need to be improved, being able to use the new technology in the efficient manner as intended. And thus these factors need to be dealt with and the barriers need to be dealt with by the SMEs. And as the small and medium-sized enterprises seem to lack resources to be able to deal with these changes, collaborative business models are in line with such kind of, let's say, shortcomings between brackets. So collaboration with, for instance, the supplier of the new technology, or cooperation with companies to buy and implement together in a joint effort the new technology. So concluding remarks. Well, hopefully I made clear that there is the alignment between suppliers, processing company, customers, consumers, and the internal elements of the different companies. The interdependencies are of importance when talking about implementing new technology and developing a new business model. So those elements, those processes, the ecosystem needs to be changed. And our research is dedicated to successfully adapt to, for companies to successfully adapt to that new technology and to serve the consumers in the profitable manner. And our next step, which is already mentioned, but the piloting, indeed, introducing new technology in companies, and our contribution to that is to find and to experiment with business models and make it tailor-made. Well, this is for me the presentation on business models. And let's go to, I would say, the question and answers.
Yes, thank you very much, Geoffrey, for your presentation. And now I would like to leave the floor to Olga de Blas from Cluster Food for the question and answer slot.
Hi, good morning, everyone. We can still see your screen, Jeffrey. If you can stop sharing, and we can see all the speakers for the question and answer slot. Perfect. Now I can see all of you.
Okay.
And the participants as well. If you don't mind, Jeffrey, we can start with you. We have a question. I think that the participant wants you to go a little bit deeper about what have SMEs need to consider before trying to implement this technology within their companies.
Yeah. Indeed, let's say that's the first stage of the introducing technology to a company, and let's say the SME needs to really think about what is exactly now the benefit of that new technology for my company, because they really need to be. They need to convince themselves of the benefit of that company, and to see the benefit and to estimate the benefit, you have to look at your company as it is. So internally, can I cope with the challenges that this new technology poses to my company? So can I embed it within the operations? Do I have the right personnel to be able to deal with those challenges? Do I have then other requirements to suppliers or not? Should I find, and then I go to the consumer side, other distribution channels to be able to reap the benefits of this new technology? So the question or the remark is simple in a sense. Well, they have to really think about the benefit of that new technology for their company. But going into the specifics, they really need to have an overview of their value chain to be able to deal with that and to take a decision on that.
Yeah, okay, thank you. That's very interesting. Now we have another question, 2 questions for David. You can switch on your microphone. The first one is about the focus groups. The person asked if you could explain a little bit more how does they work, at least the on-site ones, because we have already seen the survey. And the same person asked about he says that the consumer needs and demands have changed due to the coronavirus crisis. If this has affected the project or the way you see the focus groups. Thank you.
Yeah, so very interesting question. So I'm just going to post on the chat because this focus group part is already published and open access, so there are a lot of details there. Just post a link in the chat, so
Perfect.
to ask the question, you can also check that. So the first part of the question, if I understood correctly, it was about how the focus groups were conducted, and yes, it was physical. It was before the pandemic, right? And so it was still possible. And basically, we had a common interview guide that was developed in English and then translated in the partner languages. And then now going by memory, maybe I don't remember all the details, but what we touched upon was what's important for them when they choose fruit and vegetables products, which products they mostly consume in their households, and why, whether they were familiar with the concept of non-thermal processing technologies and what they knew in advance. And so we had a discussion around that, which is what I mostly focused in this presentation. And then we talked about food waste and in their households and reason for that from a qualitative point of view. And like I said, we had a little bit short of 100 people in total, and we had about equal amount of men and women, and we focused on 2 age groups, 18 to 30 and 45 to 60, because we know that these groups typically have a much different spending power, and the other requirement was that they would have to be responsible for groceries in their households. So there was I think the main recruitment criterion. Regarding the other parts of the question, I think that's an interesting point. I mean, I would imagine that I mean, we already see that health benefits was one of the most important things for them, and if anything, I think that after the pandemic, this motive is even more relevant to consumers. At least, I mean, there is some literature on how the pandemics and the lockdown has affected dietary habits and yeah, I mean, I think fruit and vegetables are already as a category experienced as a healthy products, but I would imagine that this has become even more you know, present in consumers' mind after Corona.
Okay, thank you. And the last one, I would say that it's for you, Oscar, but I'm not really sure if you are going to be able to answer. The person asked that these technologies are used with flexible packaging, and he asked if you are doing any test to use them also with glass or non-flexible packaging.
Yes, I can answer that. When we are talking about the use of flexible packagings, I guess the person who asked was talking about high pressure processing. Of course, in this case, the flexible packaging is needed just to absorb the pressure and do not break during the process. But also, I was able to see a presentation last week of a high pressure processing company, and they already advanced a little bit. And you, for example, you can put all the liquid, all the juice or smoothie into a flexible, huge bag, and then do the processing. And after that, do the bottling or the packaging. Yes. So there are different options to do it. In the case of the application of, for example, we are studying that we can apply the light on the product, but also with the product already packaged. In that case, we need to see the characteristic of the package, the film, the plastic, what kind of plastic we are using. I'll say, let's say plastic or polymer. And what else it involves packaging? I guess only those two can be done with bottling or with package. In the case of the ultras, we apply them before the packaging of the bottling. And I guess I hope the answer is okay for the.
I think so, yeah. Thank you very much. And that's all. We don't have any other questions. So Simona, I give you the floor to the concluding remarks. Thank you, everyone.
Thanks a lot, Olga. Thanks to participants for these interesting questions, and also to our panelists for being so clear in their explanation and answers. And again, I would recommend you to surf and visit our project website. You will find plenty of publications and information and documents, so they could be helpful for you to know more about SHEALTHY project and how we are going to run our research and innovation activities. And before we let you go, on behalf of the World SHEALTHY Project Consortium, I really want to thank you all for taking time for being present here. So thank you so much. And yes, follow us on our social network. Thank you so much. Have a nice day. Bye.